So, children, today physics chapter 2, work per energy is numericals we are doing, right? Okay, come on. Uh, Question number 1 of 2A exercise. We begin with 2A exercise, right? Okay, come. The question is a body when acted upon by a force 10 kgf. So, whatever is the data given, we will pick from the question. Yeah. Force 10 kgf. Kgf means gravitational units. So you want to convert it into SI units. That is into newtons you have to convert. Okay. So force is taken 10 kgf, which is converted into newtons by multiplying with acceleration due to gravity. In the question, acceleration due to gravity, you are asked to take, you see, it's 10 newton per kilogram is asked to take. So take that. So 10 kgf into 10 newton per kg. On multiplying, you will get 100 newton. Displacement. Question says gets displaced by 0.5 meter. That is the displacement. So F and S are given. You are asked to find the work done in 3 different ways. What are they? Question number 1 wants you to do in the direction of the force. The displacement is in the direction of the force. Whenever the displacement is in the direction, look at the diagram. This is the body. The body which I've labeled. I'm showing it again. This is your body. The force is in the first case, the force is the 10 kg of force is in the direction in which it is being displaced. So displacement 0.5 meter in the direction of the force. So we have the angle 0 degree with the direction of force and direction of displacement. They have angle 0 degree in between them. So first part, displacement is in the direction of force. We have W is equal to F into S. The expression we will use F into S only. The theta component we will not take. And of course, theta component we will not take. So 100 into 0.5, you get 550 joules. Second part, you have to find the work done. Yeah, work done when the displacement is at an angle of 60 degree. That is the second. I just mentioned this is the second part in 60 degree. So I've just made it here. This is, that means displacement and the force direction is this one, displacement is in this direction. So the angle between them is 60 degree. Then cos theta component has to be used. So we are having this displacement is at an angle 60 degree. W is equal to F into S into cos 60 we have to take. So cos 60 is 1 by 2. So 100 into 0.5 into 1 by 2 on solving you get 25 joules. Third part, you are asked to find the work done if the displacement is in the direction normal to the force acting. So the angle here mentioned is, can you tell me? It is in 90 degree. So displacement normal to the force means theta equal to 90 degree. So cos 90 we may have to use there. Cos 90 is 0. So 100 into 0.5 into 0, which is 0 joules. Done. Moving to question number 2. Yeah. A boy of mass 40 kg, 40 kilograms is the mass given. Okay, mass is 40 kg. It climbs up the stairs and reaches the roof at a height of 8 meters in 5 seconds. So mass is given M, H is given height and time is given. You calculate the force of gravity acting on the body. Force of gravity means the weight of the boy, which is mass into acceleration due to gravity. Always check within the question, acceleration due to gravity is given or not. Yes, here it's given, take G equal to 10 meter per second square is said. So you take 10. Children, if it is not given, you have to take it is 9.8. From your side, if you take, it should be 9.8 meter per second square. Okay, mass is 40 kg, height is 8 meter, time given is 5 seconds. Given data you are writing along with the G that's applied to you. Okay. Now, first part is force of gravity acting on the body. Force of gravity is the weight of the boy. Weight means mass into acceleration due to gravity. 40 into 10 comes to be 400 Newton is the weight. Second part, the work done by him against the force of gravity. Work done against the force of gravity is the energy spent in lifting it 8 meters. That is height factor also is coming. That is potential energy. So work done against gravity equal to mass into acceleration due to gravity. It is the weight or is the force. And H is the displacement. mgh 40 into 10 into 8. We are getting 3200, 3200 joules. Third portion is power spent by the boy. The work done upon time. Here power is equal to work upon time. 3200 by 5. You are getting 640 watt. All the answers are given in the question under that. It's the same. Next, a man spends 6.4 kilojoules of energy in displacing a body of 64 meter in the direction in which he applies the force in 2.5 seconds. So the variables are kilojoules. This is the energy. So energy is used to do the work. So always we can equate energy as work done. Okay, energy equal to work done, which is equal to 6.4 kilojoules, which you have to make into joules by multiplying with 1000. So 6400 joules it is. Displacement 64 meters. Time is 2.5 seconds. Then what you are asked to find, calculate the force applied and the power spent in horsepower by the man. So first of all, force applied, we are finding the force. Force term is there in the work done expression. Work is equal to F into S. Work done is given 6400 joules. We have converted now 6.4 kilojoules. Then F into the displacement 64. Solve for F. We are getting 6400 by 64, which is equal to 100 Newton. Force is in newtons. Second part is power in horsepower. You have to calculate in horsepower, but first you have to find out the power in watt. Then you relate it to horsepower. Okay. So first normal way, you find power is equal to work done upon time. Work done is 6400 joules. Over time is 2.5 seconds. You will get 2560 watt. This is a partial answer. This is in watts. You have to convert it into horsepower. By taking this relation, we know 746 watt is equal to 1 horsepower. Okay, therefore 1 watt equal to unitary method. Basically 1 watt is equal to 1 over 746 horsepower. Therefore 2560 watt equal to multiply with 2560. You get this much horsepower. 3.43 horsepower is the answer. Question number 4. A weight lifter lifted a load of 200 kgf. The load is kgf. In kgf means it's a force. Remember, it's a gravitational unit. You may have to convert it into newtons by multiplying with acceleration due to gravity, which is given in the question 10 Newton per kg. Okay, lifted a load of 200 kgf to a height of 2.5 meter in 5 seconds. Similar, same things are given. The force, the height, the time. You may be asked to find the work done or the power, etc. Okay, force given is 200 kgf, which you multiply with the acceleration due to gravity to get 2000 Newton. Displacement is 2.5 meter. Work done, you have to calculate work done if W is equal to F into S. Substitute, get 5000 joules is the answer. Second part, the power developed by him. Power is work upon time. Work upon time, 5000 by 5. We are getting 1000 watt. That's it. Question number 5. A machine raises a load of 750 Newton. Again, it's in Newton directly given through a height of 60 meter in 5 seconds. Calculate energy spent. Whenever energy spent comes, it's a work done. Okay, by the machine. Then the power of the machine if it's 100% efficient. What is the meaning of 100% efficient? No loss of energy is happening. Yeah. Force given is 750 Newton, displacement is 16 meter, time is 5 seconds. Energy spent is equal to work done. So it's F into S. Okay, this is the way you have to equate energy equal to work done's expression you write. 750 into 16, you get the answer 12,000 joules. Okay, then second part, power of the machine, if it's 100% efficient, work upon time. That's it. 12,000 over 5, 2,400 watt is the answer. Question 6. An electric heater of power is 3 kilowatt. Okay, is used for 10 hours. Kilowatt and hour are the units given. So when you solve, you have to make it into watt. Kilowatt, you have to convert into watt by multiplying with 1,000. Hour, you have to convert into seconds by multiplying by 60 and 60. 2 times 60. Yeah. But in this first part, you have to answer, express your answer in how much energy does it consume? Express your answer in kilowatt hour. The first part is in kilowatt hour only you want to do. That means take 3 kilowatt and 10 hour only for finding out. Okay. So power is 3 kilowatt. For the second part, we want to do it in joules. Na? So you make it into watt by multiplying with 1,000, 3,000 watt. T is equal to 10 hours, which is equal to 10 hour into 160 you multiply, you get into minutes. Again into 60 when you do, you will get into seconds. 36,000 seconds. 6 6 are 36, then 3 more zeros. Fine. Energy in kilowatt hour is the first part. Energy is work done, which is equal to power into time. What is this equation, children? This is actually, we know power is equal to work upon time, right? Work upon time. So from this, when time is multiplied with the power, you get work. So we can rewrite this equation. Work is equal to power into time. Okay. So I've directly written that equation. Energy equal to work equal to power into time I'm taking. So power in kilowatt, and time in hour. On multiplying, you get 30 kilowatt hour. This is the first part. Okay. Answer to the first part. This is energy in kilowatt hour. Second part is energy in joules. You want to do in joules, I told you 3,000 watt you have to take. Work done is again power into time, but power you have to take 3,000 watt into time in second, 36,000 seconds, which is equal to 108, 6 more zeros. 36 into 3 is 108, then 3 and 3, 6 zeros, this much joules, which you can rewrite it as 1.08 into 10 raised to 8 joules. How it comes 1.08? You are shifting the decimal place from here to 1, 2, 3, 4, 5, 6, 7, 8 places you are shifting. So 10 raised to 8 is coming as the multiplication factor. Yeah. Question 7. A water pump raises 50 liters of water. Therefore, यहाँ पर volume is given through a height of 25 meters in 5 seconds. Okay. Instead of mass, they have given the volume, but they have given what is the density of water. Density of water, 1,000 kilogram per meter cube is given. So what you have to do is, we know we have an equation. Density is equal to mass upon volume. This is the equation to find density. So volume into density is the mass. So if you want any time mass is to find and volume is given, multiply it with the density, you will get the mass. Okay. So in the question, volume is given. We want is mass. And density also is given, multiply with it. So go through. Yeah. It is given volume equal to 50 liters, which is actually equal to this much meter cube. Okay. Mass, this is a meter cube volume because G given is kilogram per meter cube. So first of all, the liters are to be converted into meter cube. I'll just show you for this question, how do you do that? It's 50 liters. You should know 1 liter is equal to 1000 centimeter cube. So 50 liters equal to 50 into 1000. That is 50,000 centimeter cube. This we want to convert into meter cube. That is our requirement. So write 50,000 centimeter cube means centimeter into centimeter into centimeter. Now what we want is each centimeter we have to convert into meter. How do you convert a centimeter into meter? By dividing by 100, by using division. Centimeter when divided by 100, this will turn to be meter. Centimeter by 100 together is making into meter. This centimeter, if you want to make to meter, again divide by 100. This centimeter also, if you want to make into meter, divide by 100. Okay, now adjust the powers, or is it the zeros you adjust? Oh. Tell me. You have 2 and 2, 4. We cut from here 2 and 2, 4. 5 by 100. 5 by 100 is 0.05 meter cube. It's coming, and this is what I have written here. Okay, so in rough work, do that much work and convert it. So this I'm not showing in the part of the question, but do you know how to convert it? I think yes. Yeah. So I wrote directly 0.05 meter cube. Yeah. Further, the height it is raising is 25 meter, time taken is 5 seconds. Density is given 1000 kilogram per meter cube. Since this is given kilogram per meter cube unit, we converted that into that volume into meter cube. Okay. Now acceleration due to gravity is given 10 Newton per kg is given. Have to calculate the power. Power is equal to work upon time. Yes. Okay. Before going so, the mass you have to calculate. From the volume, mass is equal to volume into density. Volume we have seen 0.05 into density is 1000 kilogram per meter cube. Per meter cube and meter cube cancels and the unit comes in kg, that is 50 kg. So basically children, you understand 50 liters of water is actually 50 kg in mass. The volume into mass relation for water is the same magnitude. The reason is the density of water is taken as a standard, and that is 1 grams per centimeter cube or 1000 kilogram per meter cube. But in this question, you are given what is the density and you are given the volume. Volume and density, when both are given, do the process for its calculation. But keep in mind, it is 50 liter is 50 kg only. Okay. So the force is the mass into acceleration due to gravity. F into S means F is the force, that is the mass into acceleration due to gravity. So 50 mass kg into 10 is the acceleration due to gravity, and S is the height, that is displacement. Over time is 5. On solving, you get 2500 watt. Question number 8. There also a water pumps reference is given. Water pump is used to lift 500 kg. Directly, you are given the mass. So no need to convert volume into mass. Okay. Water from a depth of 80 meter in 10 seconds. Mass, M, H, and S are given. Calculate the work done by the pump. Mass, height, and time, and acceleration due to gravity in the question is given 10 meter per second square. So take that. Work done is equal to increase in potential energy. Either you can write increase in potential energy, or you can write F into S. F is the mg, the weight, into H is the displacement. Any one of these equations you can do. On applying, you will get 4 lakh joules, 4 into 10 raised to 5 joules. Power, second part is, B part is power at which the pump works. Power is work upon time, 4 into 10 raised to 5, that is 4 lakh upon 10, which is equal to 40,000 watt, which is further equal to 40 kilowatt. Any one of this is Chalega. Okay, coming to third part is slightly different and new for you. The power rating of the pump if its efficiency is 40%. The efficiency in one of the previous questions, we did efficiency 100%. So what was the power input? Was the power gained? Energy spent was fully used to do the work. In this case, only 40% energy given, supplied is, whose 40% only is being used into output, or we say the power output. Okay, here in the question they are giving efficiency is equal to useful work obtained from the power that is input, which is the power rating of the machine. Initially, what was rated on when it was bought new, it was having a higher power, that is 100% efficient. Later on, by tear and wear of the machine parts, its efficiency is reduced to 40%. That's the situation. Yeah. Power rating, if efficiency is 40%, we know or given efficiency equal to useful power upon power input. On rearranging the power input, I bring here, which is called the power rating of this machine, this motor. Initially, when bought, how much, what was the power written on it? That is called power rating. That is the power input. Equal to useful power over efficiency. Useful power is in the second part, B part, what you have calculated, power 40 kilowatt. Yeah, 40 kilowatt over 40% is the efficiency, 40 by 100, the 100 goes on the top, 40 and 40 gets cancelled, you get 100 kilowatt. Which means when you bought this as fresh, it was having a power rating 100 kilowatt, but now it is showing only 40 kilowatt. That is what we obtained in the B part, the power. Okay, move on. Two smaller questions are solved here. An ox can apply a maximum force of 1000 Newton, force equal to 1000. It can take, it is taking part in a cart race and is able to pull the cart at a constant speed of 30 meters per second. It's a velocity, speed is given. Okay, now you have to find, while making its best effort, calculate the power developed by the ox. We know the equation, power is equal to work upon time. And we know work's expression is F into S. So power can be written as F into S upon time. Here, S is the displacement, T is the time. Displacement upon time is actually velocity. So we can take the equation F into V. So power, you can calculate using the force and the speed. Okay. If these two are the data given, use the expression P equal to F into V for calculating power. So force is 1000, velocity is 30 meters per second, units are in the same system. So solve it, 30,000 watt, which is equal to 30 kilowatt. The other way, if you want to solve, you can also solve it in this manner, children. The method I said, power equal to work upon time equation, you write. Work is F into S, you write. Force is given 1000 Newton. The speed it's given in the question is 30 meters per second, which means in 1 second, 30 meters per second means in 1 second time, it covers 30 meters, which you can take this as the displacement, this as the time. So S and T, 30 and 1 you substitute, what you get is the same answer as before. Okay, displacement is 30, time is 1. We are getting 30,000 watt. Okay. 10th question on the right side. Power of a motor is 40 kilowatt. At what speed can the motor raise the load of 20,000 Newton? Same F into V equation will use. Power is 40 kilowatt. You want to make it into watts, no? Kilowatts, you have to convert into watt, which is equal to 40,000 watt. Force is 20,000 Newton. Velocity you have to calculate. P is equal to F into V, therefore V is equal to P by F. P by F, you get 2 meters per second. 11th question, again, same equation. Rajan exerts a force of 150 Newton, pulling a cart at a constant speed of 10 meters per second. Calculate the power exerted. P equal to F into V. F is 150 Newton, V is 10 meters per second, 1500 watt. Question number 12. A boy weighing 350 Newton climbs up 30 steps each 20 centimeter high in 1 minute. Time is given in minute, you have to convert it into seconds to learn. Yeah. So try to understand the concept. A boy stands here, is climbing 1 step, then 2. This way 30 steps he is climbing. Each step has a height of 20 centimeter, which means the total height is 30 times 20 centimeter. So from this, the total height is 30 into, this is the h you have to calculate. 30 into 20 centimeter and make it into meters then. Okay, boy climbs 30 steps each with 20 centimeter, means the total height he climbs is 30 into 20 centimeter, which is equal to 6 meters. 600 centimeter, which is equal to 6 meters. Force is 350 Newton. This is the mg, the weight. Time is 1 minute, which is equal to 60 seconds. Work done is equal to mgh. Against gravity, gravitational potential energy, 350 into 6, 2100 joules, 2100 joules. Power spent is equal to work upon time, 2100 over 60, 35 watt. Question number 13. It takes 20 seconds for a person A of mass 50 kg to climb up the stairs, while another person B of the same mass does the same in 15 seconds. Compare the work done, power developed by the persons A and B. Comparison question. Okay. Since both the persons' mass is the same height they have to cover, and at the same place, so acceleration due to gravity also is the same. What we can say is the work done is the same. So 1:1 is to be the answer, but we have to prove it. Yeah. The work done W by both the persons A and B is the same as their mass and height h to climb are the same. So case 1 for person A, time taken is 20 seconds, mass is 50 kg, height, let us take h. W1, I calculate, it is 50 into GH, mgh. Okay, M1 is the 50, G and H I write, keep the equation as 1. We cannot calculate because the height is not mentioned. It is at certain height. Okay, climb up the stairs only it is mentioned. All right. So at present, leave it as in an equation because on finding the ratio, the G and H will be getting cancelled. Okay. Power also we can leave in the form of an expression. Power is work done upon time, 50 into GH upon 20 seconds. So time being, I just stress only 2.5 into GH. This is equation number 2. Person B, time taken is 50 seconds. Mass is the same mentioned in the question, that is the initial person's A's mass. Height also is the same. Work done equal to 50 into GH. The same we are getting. You can mark this as equation number 3 if you want. Then power is again 10 by 350 GH over 15, which is equal to 10, 15 and 50 you cut with 5. So 10 over 3 GH, you mark it as equation number 4. To find the ratio, compare means you want to find the ratio, children, the work done. So W1 over W2, you have to do 50 GH over 50 GH 1 by 1. So the answer you write W1 ratio W2 is equal to 1 ratio 1. Power, again P1 by P2 you do, you get this 3 by 4. How? The cutting you do 0. Oh, better 50 and 50 directly we can cut, children. Yeah, 50 and 50 you cut, G and G, H and H, 15 and 20, 3 by 4 you are getting. 3 and 4 you are getting. Yeah, P1 by P2 is 3 by 4. So P1 ratio P2 equal to 3 ratio 4 you have to mention. Question number 14. A boy weighing 40 kgf climbs up a stair of again 30 steps each with 20 centimeter height in 4 minutes. And a girl weighing 30 kgf does the same in 3 minutes. Compare. This is a board question, 2016 question. Compare the work done by them and the power developed by them. In a similar way, we have to take two cases, one for boy and the other for girl. Okay, for boy, that is case 1, weight 40 kgf. When comparison is there, you need not to convert it into newtons because kgf in both the cases it's kgf, so we'll be getting cancelled. Okay, mass is 40 kg. From this kgf, but the weight we can take 40 kg as the mass. 40 kgf, children, is the weight, so the mass is 40 kg. Okay, and total height is 30 steps each with 20 centimeter. Like before, only it is 6 meter. Time is 4 minutes, which is equal to 4 into 60 to 40 seconds. Work done is equal to M1GH 40 into 9.8 into 6. I'm calculating it. Though it's not asked to calculate, only comparison. So I calculate it. We can do the expression while taking the comparison. Fine. Power work upon time divided by 240 seconds. You are getting 9.8 watt. That of girl, but you should do on the next line. Na? I don't have space. My page is in landscape form, so I'm keeping it here on the right side. Weight of girl is 30 kg, so mass is 30 kg. Height, the same height. Time is 3 minutes, which is 180 seconds. Work done by the girl, M2GH 30 into 9.8 into 6. It's coming to be this calculation. For comparison is not necessary, but I've done. Power that upon 180, 9. Watt again, 9.8 watt. Yeah, first part of the question, comparison of their work done, W1 ratio, WT up to 5, W1 by W2. I keep them as expression so that we can easily get them cut. 9.8, 9.86 and 6, then 0 and 0, 4 by 3, which is 4 ratio 3. We will answer. Power 9.8 watt over 9.8 watt, 1 by 1, so 1 ratio 1. Fifteenth question. A man raises a box of mass 50 kg to a height of 2 meters in 20 seconds. While another man raises the same box means mass is the same height is the same, but the time is different, 50 seconds. Compare work done, the power developed by them. Calculate the work done, because in this, the work done is to be calculated. In the previous question, it was not asked to calculate, but I calculated, I told you. And the power developed by them. Yeah. Mass. First person 1 is 50 kg. You can mention first person 1. This is for person 2. Yeah. Person 1, the mass is 50 kg. Height to raise the box is 2 meters. Not the person one's, the box is mass. Okay. Mass of the box is 50 kg. To raise 2 meters in 20 seconds by the first person. In the question, you are asked to take G equal to 10 Newton per kg. So you take that. M1G H1 50 into 10 into 2, 1000 joules. Work done of the first person we have calculated. Then power developed by him, 1000 by 20, it is 50 watt. Yeah. Then the second person, mass of the box is the same. Height is, that is mass of the box. In this case is same box as that of the first case, so it's 50. Same way, height to lift is same as that of the first case, which is 2. Time is 50 seconds. So on calculating work done, 50 into 10 into 2, it's coming to be 1000 joules only. Power 1000 by 50, it is 20 watt. Now coming to the question, compare the work done, W1 ratio W2. Take the W1 is 1000 joules, W2 is again 1000 joules. So W1 by W2 equal to 1000 by 1000, 1 by 1, which is 1:1. Power 50 by 20, which is 5 by 2. So the ratio is 5:2. 16. A boy takes 3 minutes to lift a 20-liter water bucket from a 20-meter deep well, while his father does it in 2 minutes. Same work in 2 minutes. Compare the work and the power developed by them. How much work each does? Take density of water is 10⁻³ kilogram per meter cube and G is 9.8 Newton per kilogram. Yeah. Time taken by the boy. Boy takes 3 minutes, which is equal to 180 seconds. Height to lift is 20 meter. Volume is 20 liters, which we have seen earlier how to convert it into meter cube. 10⁻⁻3. If you can remember, you simply apply. If you don't know, solve it the way that I had shown. 20 into 10⁻³ meter cube. Density is given 10⁻³ kilogram per meter cube. So the mass is volume into density, that is 20 kg. Children, I told you 20 liters of water is 20 kg of water. Okay. Then work done by the boy. W1 kg, I'm writing work done by the boy is equal to M into G into H. Mass 20, G 9.8 and H is 20, which is 3920. 3,920 joules. If you want, you can write it is 3.92 kilojoules. Okay, power developed by him is work done by the boy over the time taken by him. 3920 by 180, which is 21.78 watt. Actually, in your book, it's not shown the answer. How much work each does? Okay, power by each one is not asked. Only comparison. Anyway, I solved it. Yeah. Father takes 2 minutes for the same work. That is 2 into 60, 120 seconds. Height is the same. Mass, I'm taking the same 20 kg here. Once calculated, need not to calculate it again. Work done by father, M into G into H, 3920 joules the same. And power not asked, but I'm solving 32.67 watt. Now, work done by ratio of their work done, comparison of their work done. If I take the expression 20 into 9.8 into 20 by the boy and that of father is in this way, 1 by 1 you get, that is 1:1 is the work done. Means children, work done will be the same because same height, same mass, same place for acceleration due to gravity also same. Power develops, we have to take the comparison. Okay, I take work upon times expression here by 180 here. Later we will rewrite it now. 20 into 9.8 into 20 divided by 180. I wrote this with this by 180. Then in the bottom we have by father. This is 20 into 9.8 into 20 by 120. This I'm writing 20 into 9.8 by 120. I take it to the top. Which on cancelling, you get a 2 by 3. So power, comparison of their power is 2:3. We are now, children, entering into 2B exercise. 2-1 exercise is over. I think 16 questions. Come to 2B exercise. Two bodies of equal masses are placed at height h and 2h. First one is at height h, the other is at 2h. Find the ratio of their gravitational potential energies. Yeah, consider this is first body kept at a height from the ground at h, and the second one is kept h and h. 2h height, this is placed. Okay. Case 1, the first body. Mass is, we are assuming, let the mass of the body, two bodies of equal masses. It is said equal masses. Let the mass of both the bodies be m kg. So m I'm taking. Second body also will have the same mass, equal mass. Height, first one is h, second one is 2h. Two cases you develop. Okay, gravitational potential energy U1, potential energy M1 GH1 MGH, M into G, H into G. Keep it as equation number 1. Okay, coming. Second one, gravitational potential energy M2GH2 Mg2H, that is 2 mgh. Keep it as equation number 2. For comparison, comparing equation 1 on equation 2, we divide now. U1 by U2 is equal to mgh by 2 mgh, which is equal to 1 by 2. So the ratio of their gravitational potential energy is U1 ratio U2 is equal to 1 ratio 2. Question number 2. Find the gravitational potential energy of 1 kg mass kept at a height of 5 meters above the ground. Calculate its kinetic energy when it falls and hits the ground. Take G equal to 10 into 10 meters per second square. Yeah. First, we have to find kinetic energy. No. Find the gravitational potential energy when it is raised through a height of 5 meters. Yeah, mass is 1 kg. Height is 5 meters. G, you are asked to take 10 meters per second square. Potential energy is equal to mgh, m into g into h, 50 joules. Kinetic energy, K, when it falls and hits the ground, will be equal to, you have to equate first, equal to initial potential energy according to law of conservation of energy. Energy can neither be created nor be destroyed. It can be converted from one form to another form. Okay, so potential energy initially what it is having is being converted completely into kinetic energy just when it hits this ground. So you can equate K is equal to initial potential energy. U was 50 joules we have calculated, which you can equate. Remember this equating, you can only do after writing this statement. Okay. Question number 3, a box of mass 150 kg has gravitational potential energy stored in it equal to 14,700 joules. This is the potential energy. Find the height of the box above the ground. So whatever is this height, we have to calculate. This is the box with 150 kg mass. Okay, so mass is 150 kg. Proceed this way. G is to be taken as 9.8, which is given in the question. U is given 14,700 joules. H. U equal to mgh, solve for H, nothing more to say, children. H is equal to U equal to this one, H is equal to U by mg. We are getting 10 meters. Question 4. A body of mass 5 kg falls from a height of 10 meter to 4 meter. 10 meter to 4 meter it is falling, which means initially it was at a height of 10 meter. Finally, it will fall down to a height of 4 meter. This is what is 4 meter. This is what is 10 meter. Try to understand. So it covers 6 meter down and reaching now final height is 4 meter. So two heights you consider H1 and H2. This is H1. This is H2. Yes. Yeah. Mass 5 kg, initial height is 10 meter, final height is 4 meter. G is to be taken. This loss in potential energy. What you are asked to find out first part, loss in potential energy of the body. Loss in potential energy is due to difference in their heights. Initial height, it was at a higher height and it was having a higher potential energy. When it falls down to a lower height, it will have lesser potential energy. In between what was there is lost. So the equation is mgh1 minus mgh2, which is mg into h1 minus h2. 5 into 10 into 10 minus 4, which is 6. On solving, you get 300 joules. Second part is total energy possessed at any instant. What is the total energy possessed? Will be equal to initial potential energy. So mgh1, which is 10, is the height. M into G into 10 height, that is 500 joules. Question 5, calculate the height through which a body of mass 0.5 kg is lifted if the energy spent in doing so is 1 joule. take G is this much. Mass 0.5 kg. Potential energy is 1 joule. G is 10 meter per second square. What is the height? Equation U equal to mgh. Calculate for h. H is equal to 1/1. So you are getting 0.2. Simple substitution. I don't have to explain, no, children. Yeah. Next question. A boy weighing 25 kgf. Kgf is to convert into Newton by multiplying with the value of G. Yeah. Climbs up from the first floor at a height of 3 meters above the ground to the third floor. 3 meters above the ground to the third floor at a height of 9 meters. Understand the question, please. The boy is already now above the ground by 3 meters height. This is the ground level. From there, he is in the first floor at a height of 3 meters. Therefrom, he is starting climbing and reaching to the third floor, which is at a height of 9 meters. Okay, so take the heights. This is H1, it is H2. Difference in the height will be the difference in their potential, his potential energy. Okay, ground. Yeah, what will be the increase in his gravitational potential energy? So there will be one potential energy U1 here. There will be a potential energy U2 here. The difference is due to the difference in height. So the same equation you apply mg into h2 minus h1. Remember, when you take h1, yeah, h2, the difference you take bigger minus smaller you have to do. Okay, so that is 9 minus 3 you have to do, which is 6. 250 into 6. You are getting 1500 joules. Question number 7. A vessel containing 50 kg of water is placed at a height of 15 meters above the ground. Assuming the gravitational potential energy at ground to be 0, what will be the gravitational potential energy of the water in the vessel? Mass, height, G given in the question. So they have mentioned assume the gravitational potential energy on the ground is 0, means the difference in gravitational potential energy, when you take the one which is there on the ground, you take it as 0. U0 is equal to 0. You are taking, that's it. So m into g into h, mass, height, mass accelerated due to gravity and height, minus gravitational potential energy at the ground, which is 0, which is 7500 joules. 8th question. Man of mass 50 kg climbs up a ladder of height 10 meters. This is a man, ladder he climbs, the height is 10 meters. Work done by the man. That is the gravitational potential energy, work against gravity. Mass 50, height 10, G is 9.8 given in the question. Work done is equal to force into either force into displacement, or you can simply take the potential energy mgh. Fact is the same. Mass into this 4900 joules. Increase in potential energy is equal to U, that is mgh, which is the same, because they have asked the same, only on ground we are assuming it to be 0. So once again, solve it, that's it. Next question, carefully listen. A block A of mass, weight it is given 100 Newton. 100 Newton weight is the force, no? Is pulled up a slope of length 5 meters by means of a constant force F, which is 100 Newton. Okay, look in the diagram. This is the box whose weight is 100 Newton and it is pulled by a force of 100 Newton again through a distance 5 meters, which is to this place. So I consider from the point A, it is reaching to the point B. But during this force, it is raised by a vertical height of 3 meters. This is what's the question. So very first time when the force is in this direction, and the displacement also is in the same direction, the work done will be F into S you have to do. Okay. Yeah. Solution. Given F is 100 Newton, S is 5 meter. Weight is also mg 100 Newton. W is equal to F into S, 100 Newton into 500 joules is the answer. B part, increase in potential energy. A part is what is the work done by the force F in moving the block A 5 meter along the slope. Okay, in the same direction. Second part is what is the increase in potential energy of the block A. Increase in potential energy is due to the vertical height it is attained, due to its weight, that is mg, which is also given 100 Newton. Anna? Yeah, increase that is increase in potential energy is equal to potential energy gained while lifting a height h, mg into h. Mg is 100 Newton, h is 300 joules. C part, account for the difference in work done by the force and increase in potential energy of the block. See, vertically when it is raised, the increase in potential energy, and through the slope when it is raised, they are different. The energies spent are different. What is the reason? The reason that the block is moving, or we say touching the slope. So the physically contacted parts will exert some friction. So some amount of energy, the difference in the amount of energy is due to the loss of energy caused, or we say spent in overcoming the friction. So first of all, you'll find the difference in energy, account for the difference in the work done. 500 joules minus 300 joules, which is 200 joules is the difference. This is used in work against the force of friction between the block and the slope that is lost in the form of heat energy. You have studied about energy degradation, energy dissipation. Yeah, some amount of energy is lost. Next, we enter into kinetic energy. Find the kinetic energy of a body of mass 1 kg moving with a uniform velocity in meter per second. Direct substitution, mass, velocity. K is equal to half mv square, half into 1 into 10 square, 50 joules. Case 2. Oh, no, that is another question. Question number 11 on the right side, children, which has 2 cases to do. Question number 11. If the speed of a car is halved, how does its kinetic energy change? So initially, let's consider the velocity. The speed is v. Now in case 2, it is halved, means it's v by 2. Initial case when velocity was v, you have to write in verse, let v be the initial velocity. Then the kinetic energy will be k1 equal to half mv square. When it is halved in case 2, kinetic energy will be equal to half m. The new velocity is v by 2 the whole square, which on solving v square by 4 you'll get. That is 1 by 4 into half mv square. I rewritten it is this way, 1 by 4 and half mv square I split, which is equal to 1 by 4 into k1, because k1 is equal to half mv square. We know k1 is equal to half mv square. So this half mv square you substitute with k1. So we are writing the final kinetic energy k2 becomes 1/4 of the initial kinetic energy. Question 12. Okay. 2 bodies of equal masses are moving with uniform velocity v and 2v. Find the ratio of their kinetic energies. Same way, the velocities are different, so accordingly solve. Case 1, when velocity is v, kinetic energy is half mv square. Mark it as equation number 1. Second, case 2, when velocity is 2v, k2 equal to half m into 2v the whole square, which on further solving half m v square into 2 square, which is 4. What do you have to do? Compare their kinetic energies k1 by k2 half and get it that way so that directly we can cut the half. If you find it's difficult, you can place them into numerator and denominator. Okay, denominators 1 by 2 will go on the numerator then. Half mv square over half mv square into 4. On cutting, you will get 1 by 4. So k1 ratio k2 is equal to 1 ratio 4. Test number 13. Two bodies have masses in the ratio 5 ratio 1 and kinetic energies in the ratio 125 ratio 9. So this I'll solve in a different way by the data which is given. This also is fine, but we cannot equate. The ratio we can take, but we cannot equate. So just a second, let me wrap it up. We are coming with the same answer only. What are given? Two ratios are given. Of what? Two bodies have masses in the ratio 5 ratio 1, which means given m1 over m2 is equal to 5 by 1. m1 ratio, m2 is equal to 5 ratio 1 means we can write it this way. So what is given exactly? You're right. m1 ratio m2 is equal to 5 ratio 1, which means m1 by m2 is equal to 5 by 1. Also, it's given k1 ratio k2 is equal to 125 ratio 9, which means k1 by k2 is equal to 125 by 9. Okay, these are the values given. Calculate the ratio of their velocities. Okay, so we know the two bodies with certain masses m1 and m2, they will have certain kinetic energies and velocities v1 and v2. So we are assuming that m1 and m2 are the masses and v1 and v2 are their velocities of the two bodies. So we know kinetic energy of the first body k1 is equal to, how do you write? Half m1 v1 square. Equation number 1. We also know kinetic energy of the second body is equal to half m2 into v2 square. I simply take the relation. That is on comparing equation 1 and 2. Or we say from equation 1 and 2, what I'm getting, k1 ratio k2 is equal to the first part of the right hand side, half m1 v1 square over half m2 v2 square I'm going to write. Okay, so this is equal to, I write this way, half m1 v1 square over half m2 v2 square. Okay, now in the question you see, children, the k1 by k2 is given as 125 by 9. So we can substitute k1 by k2 is equal to 125 by 9. This is given, is equal to. So this k1 by k2 is substituted by 125 by 9. Second, one more relation is given in the question, that is m1 by m2 is equal to 5 by 1. Okay, so this m1 by m2 also I'm rewriting with the values. Before moving, so I'm just cutting the half and half from the numerator and denominator. So what I'm left with is only the m1 by m2 substitution is 5 by 1. And this will be v1 square over V2 square. What you have to calculate is V1 square by V2 square. From them, V1 by V2 we have to calculate. So keep this part here, and 1 and 5 you take to the left side. So on rewriting further, this will become 125 into 1 by 9 into 5. Okay, 5 and 125 you cut to get 25 on the numerator. This you cut, you'll get 25. 25 by 9 you are getting. What is? This is V1 square by V2 square. Okay, I continue here. So we got V1 square by V2 square is equal to 25 by 9. So taking square roots on both sides, which will be V1 by V2 is equal to square root of 25 by 9. Which is square root of 25 by square root of 9, which is equal to 5 by 3. V1 by V2 equal to 5 by 3. So we can write the V1 ratio, V2 equal to, compare the velocities, okay, V1 ratio, V2 equal to 5 ratio 3. Got it? Next, a car is running at a speed of 14 km per hour. Speed, remember it's in kilometer per hour. While another similar car is moving at a speed of 45 km per hour. Find the ratio of their kinetic energies. Since the ratio is asked, you don't have to convert kilometer per hour into meter per second. It will be cancelled, and similar units will be cancelled. Okay. So velocity of the first car is 15 km per hour. That of the second car is 45 km per hour. Kinetic energy with that velocity can be calculated. Children, again look on to the mass. A car is running at a speed of this much, while another similar car. Look for the word. Similar means mass is the same. For M, we can let M be the mass of both the cars. Yeah. So half into M into 15 square. And this is half into M into 45 square. So compare the kinetic energies. K1 by K2 is equal to half M 15 square by half M 45 square. Cutting and cancelling, you'll get 1 by 9, and the ratio is 1:9. Next question on the right. A ball of mass 0.5 kg slows down from a speed of 5 meters per second to that of 3 meters per second. Velocities are changing. Initial velocity 5 meters per second, final velocity 3 meters per second. Calculate the change in kinetic energy of the ball. Change in kinetic energy is equal to half M into V1 square minus V2 square, whichever is the bigger one square minus the smaller one square, change in kinetic energy. Okay. So, or you can first write kinetic energy of the initial velocity, kinetic energy with the final velocity. Half M is common. So V1 square minus V2 square, half into M into V1 5 square, V2 square is 3 square, 5 square is 25, 3 square is 9, 25 minus 9 is 16. On solving, you get 4 joules. Question 17, a body of mass 10 kg moving with a velocity 20 meters per second. If the mass of the body is doubled, remember mass is doubled and velocity is halved. So 2 cases you have to develop. Then find initial kinetic energy and final kinetic energy. Separately you solve, that's it, no comparison even. So case 1, mass 10 kg, velocity 20 meters per second. Mass, velocity, kinetic energy is half mv square, 2000 joules. Second, mass is doubled. So mass is 20, velocity is halved, this is 10. Okay, 20 and 10, with that you calculate, you get 1000 joules. Sometimes this question can further be asked, compare the kinetic energies, then do K1 over K2 you do. Question 18. A truck weighing 1000 kgf. This is kgf. So look for G. If present, you take that. Otherwise, 9.8 you have to take. Changes its speed from 36 km per hour to 72 km per hour in 2 minutes time. Calculate the work done by the engine, its power spent. There is no comparison. So kilometer per hour, you have to make it in meter per second. Yeah. Weight mg is 1000 kgf, which is equal to into 10, that is 10,000 Newton. Initial velocity 36 km per hour is equal to 10 meter per second. How to convert, children? Kilometer per hour into meter per second. First you write 36 kilometer per hour. You write this way. We need this kilometer to convert into meter. How do you convert kilometer into meter? By multiplying by 1000. So you made the kilometer into meter now, 36 into 1000. It's come in meter. R, how will you make it into second? By multiplying with 60 and 60. Then cut. What are to cut? 0, 0, 0, 0. Then this 6 and 36. First you get 6, this 6 and 6. You are getting 10 meter per second. This value you get. I hope it's clear. Same way, you convert 72 meter per second, a kilometer per hour also. This becomes 20 meter per second. Okay, time is 2 minutes, convert into seconds, 2 and 20 seconds, 2 into 60, 120 seconds. Yeah. Work done is equal to, but this work energy theorem now. Work done is equal to increase in kinetic energies equation. According to work energy theorem, the work done is equal to increase in kinetic energy. Half m into change in kinetic energy, 20 square minus 10 square. 20 square is 400. 10 square is 100, which is 300. On multiplying and dividing, you'll get 1,50,000 joules, which is equal to 1.5 × 10⁵ joules. Power, that value divided by time, 1,250 watt. Question 19. A body of mass 60 kg, momentum of 3000 kilogram meter per second. Momentum is P equal to mv. Yeah. Mass is 60 kg. Momentum is 3000 kilogram meter per second. You have to calculate kinetic energy and speed of the body. K and V you have to calculate. Use the equation of kinetic energy and momentum. We know K is equal to P square by 2m. Okay. First part. So P is given 3000 square by 2 into the mass. On solving, you get the answer. Second part, the speed or velocity. The kinetic energy you got here, that is 75,000 joules you substitute here. We know kinetic energy is equal to half mv square. Substitute that kinetic energy calculated in first part here, half into mass into v square. Solve for v square, you are getting 50 meter per second. Okay. Then 20th question. How much work is needed to be done on a ball of mass 50 gram to give it a momentum 5 kilogram meter per second? Again, mass and momentum are mentioned. Ball of mass converted into kilogram. Momentum is 5 kilogram per meter per second. Work done is equal to kinetic energy. The kinetic energy is doing the work. Work equal to energy. So work is equal to kinetic energy is equal to P square by 2m. P square by 2 into mass, you get you're getting 2050 joules. Question 21. How much energy is gained by a box of mass 20 kg when a man carrying the box weighs for 5 minutes for a bus. Children, a man is standing and holding a bag in his hand. That's it. He is holding a bag in his hand and standing there. There is no displacement. And now there is no movement of the bag. So the displacement is 0. This term displacement will be taken as 0. That's what you do. Work done is F into S. F is mass into acceleration due to gravity 20 into 10, but into 0 will make it to 0 joules. Then second is runs carrying the box with a speed of 3 meters per second to catch the bus. So it is possessing kinetic energy. K is equal to half mv square. Kinetic energy half into mass into velocity is 3 meters per second square, 90 joules. Then raises the box by 0.5 meter. Inside the bus, he is lifting and placing it at a carrier. That's it. Raises. The height is 0.5 meter. U is equal to mgh, mass into acceleration due to gravity into height, 100 joules. Okay, next question is a little tricky. Please understand. A bullet of mass 50 gram. I took mass 50 gram, which is into kilogram, converted to kilogram, is moving with a velocity 500 meters per second. Initially, the bullet is moving with a velocity. This one, that is initial velocity u. It penetrates 10 centimeters into the still target and comes to rest. First of all, you understand the situation which is going by. This is the bullet whose mass is 50 grams. It is moving with a velocity, initial velocity 500 meters per second. Very great, very high velocity. And it collides or strikes a still target. What is the meaning of still target? Maybe a tree or a wall or so. This is the still target. It strikes at that. What happens to it? It will penetrate with a great velocity. It is coming. That is, before it gets stopped, it will penetrate into it. And that distance into which it is penetrating is 10 centimeters. And finally, it comes to rest, means the final velocity will turn to be 0. So these all things you have to imagine and take it in accordingly. Initial velocity u equal to 500 meters per second, with which is initially moving. Displacement is 10 centimeters, which is equal to 0.1 meter. Final velocity is 0. Kinetic energy is equal to half m initial velocity, this much. Solving 6,250 joules. Second part you are asked to find is the average retarding force offered by the target. Force is equal to ma. But here, instead of acceleration, it is retardation, which is negative acceleration. Okay, so retarding force to calculate, we need to calculate by equation. We'll calculate acceleration. It will be negative. Using that, we'll find the force. That also has to be negative. I'll put that. Okay, to find acceleration, use the equation v square equal to u square plus 2as, where final velocity we have, initial velocity we have, displacement 10 centimeter we have. On substituting these values, we can calculate what is the acceleration. Look at 0 square 500. Okay, one second. Yeah, it is final velocity is 0 square, initial velocity 500 square. Now I'm writing plus 2 into a into displacement is 0.1 meter. Now this 2a into 0.1, which is adding at the right side, I'm taking to the left side, which will be which will be becoming negative. Either you can take minus 500 portion negative. That will be better, na? I'm keeping the negative sign on this place. Negative 500 square I'm keeping. This I'm shifting to the left side. 500 square I'm taking to the other side. So that will be minus 500 square, isn't it? Negative value of this one. And 2a into 0.1, you keep at the same place. So out of which a is equal to, you will get negative, this value you get. On solving, you are getting minus A is equal to minus 1002 meter per second square. 12,50,000 meter per second square in negative we are getting. So A is negative means there is a retardation, that is negative sign shows a retardation. So retarding force will be F equal to MA, where you will be taking this is negative, and hence this answer you are getting a negative sign. Now you will write here also the force, the retarding force. The force is negative. Here you will write the negative sign. Shows the retarding force. That is what is asked to calculate. Retarding force is, the answer you will write it is in positive because we use the word retarding. The negation we have already mentioned. Force is equal to 62500 Newton. Retarding force is this much Newton. The force developed is minus 62,500 Newton. I think it's clear. The last question of 2B. A spring is kept compressed by a small trolley of mass 0.5 kg. This is a small trolley with 2 wheels and is made to place towards a still target, maybe a wall or so, or on a platform it is towards a wall using a spring. It is made kept compressed. Okay, the spring is in the compressed stage. So when the spring is in the compressed stage, and you know it is having stored potential energy. But when we release it, it will go with a velocity, that is, it will attain kinetic energy. The compressed form, the stored potential energy is transferred or converted into kinetic energy for its motion. Okay, understand? So lying on a smooth horizontal surface as shown in figure, when the trolley is released, it is found to move at a speed of 2 meters per second. What potential energy did the spring possess when compressed? The potential energy possessed by it when compressed is equal to the kinetic energy gained by it when released. That is the relation that you have to take. So mass and velocity. Potential energy possessed while compressed is equal to kinetic energy gained on releasing. So you solve half mv square, 1 joule potential energy it was possessing because that is converted into kinetic energy. Yes. Okay. This is the last of second B exercise. Now 2C is remaining, which I'll be sending shortly. Okay, children. I hope you understand.